This is lesson 2.3, multiplication with fractions in the area of a triangle in pre-algebra. So first of all, what we're going to do is we're going to work with the multiplication of fractions. And when we're multiplying fractions, like example 1 shows, what we do is we multiply the numbers on the top, the numerators, and then we multiply the numbers on the bottom, the denominators. And once we do that, we are done. If we have a fraction times a whole number, like 3/8 times 5, as in example number 2, we need to write the 5 as a fraction. So whenever you're given a whole number and you need to write it as a fraction, you just put it over 1, and then you multiply your numerators, and you multiply 8 times 1, and you get 15 over 8. Now, one of the little tricks when you're multiplying fractions is, let's say that you want to take 1/2 of a fraction. Alright, the ideal way of doing that is to just take 3/8 times 1/2, multiply the 3 times 1 and get a 3, multiply the 8 times 2 and get 16. Now notice, we started with 3/8 and we ended with 3/16. The numerator stayed the same, as it always will. The denominator, look what happened to it. It went from an 8 to a 16. So if you want a real quick and easy way to multiply a fraction times 1/2, or anytime you want to take 1/2 of a fraction, you just take the denominator and you double it, and the numerator stays the same. So if we have 3/11, half of that would be 3 over double the 11, 22. If we have 1/17 and we want to take half of that, 1 over double the 17th, 34. If we have 7/16 and we want to take half of it, you double the denominator. And that's it. So you can real quick and easily in your head be able to determine what half of any fraction is just by doubling the denominator. So this is example 3, and not really a whole lot to this. I mean, you've got 3 fractions. The ones in the parentheses, you're multiplying them together, and then you'll multiply that by 1/2. So 3/4 times 1/5 would be 3 times 1 over 4 times 5. And then we multiply the other 2 fractions, 1 times 3 over 2 times 20. And we get 3 over 40. And it really doesn't matter what order you multiply. We could have multiplied these 2 first and then taken that answer times 1/5. It doesn't matter when you're multiplying what order. The only thing that matters is what's the easiest way to multiply. So if it's easier to multiply 1/2 times 3/4 first, then multiply it by 1/5, go ahead and do that. But it doesn't really matter what order, it's just whatever makes it easiest for you. So if we have 15 over 8 times 4 over 9, as in example number 4, we can multiply this out and get 60 over 72, and we notice that both of those numbers, the 60 and the 72, are even numbers, so we know that this can be reduced. So what we're going to do is we're going to write this as a product of primes. So we're going to write 60 using our factor tree, and it's 2 times 2 times 3 times 5, and that's over 2 times 2 times 2 times 3 times 3. And then we can cancel out what's common, and we get 5, 6. Okay, so that's one method of doing that. There is another method. There is some ways to make this a little bit easier. And that's what they're showing as a continuation of example 4. They're saying, you know, there is another way to do this. And what that way would be to take 15 and write it as the product of primes. 8 is the product of primes. 4 is the product of primes, and 9. And once you do that, then you can cross this 3 with this 3, this 2 with this 2, this 2 with this 2, and what do we have left up here? A 5. What do we have left down here? We have 2 times 3 is 6. So that's a lot easier to find the product of primes of small numbers rather than wait till you get 60 over 72 and have to figure out the product of primes by doing the factor tree of 60 and then the factor tree of 72. Whereas when I just used what I have over here, the 15 and the 8 and the 4 and the 9, I didn't need to make a factor tree. I just did 3 and 5 and 2, 2, 2, and 2 times 2 and 3 times 3. It was just real easy to do that in my head. So that's a shortcut way of doing that, and that'll really help you, because what you're doing basically is you're reducing the fraction before you multiply. So this is example 5. The only difference between this one and one that we've done before is this minus sign. That minus sign is going to be used because when we multiply a negative number, it doesn't matter if it's a fraction or a whole number, times a positive number, we know our answer is going to be negative. So just keep that in mind. So what we're going to do is we're going to write the product of primes for 9, the product of primes for 2. 2 is already prime, so you don't do anything. 2 times 2 times 2. And 18 is going to be 2 times 3 is 6 times 3 is 18. Now notice when I'm canceling a number there, and I'm going across the multiplication sign and multiplying from another fraction. That's okay. As long as the sign between these two fractions is a multiplication or a times sign, I can multiply, or I can cancel across. If this were a plus sign or a minus sign, I couldn't do this. But because it's multiplication, I can do that. So I can cross out those two. I can cross out those. That one, and that one, that one, and that one. And I'm left with the 2. And I have to remember I'm going to get a negative on there, so I've got to put a negative 2 on that. So don't forget to do that. This is example 6. We've got 3 fractions we're going to multiply, and we're going to do them the exact same way. Product of primes. 2 and 3 are already primes, so I don't have to do anything there. 6 is 2 times 3. 5 is just a 5 because that's a prime. And this 5 is prime, and that 8 is 2 times 2 times 2. And then at this point, I just have to start canceling. So I'm going to cancel that 3 with that 3, that 5 with that 5, that 2, and that 2. And I'm left with nothing on the top. When there's nothing on the top, it's always a 1. And I have this 2 right there that shows up. So my answer is 1/2. Okay, let's look at example 7. We have negative 3/4, and we're going to put that in parentheses and square it. So what that means is we're taking negative 3/4 times negative 3/4. And that's because, if you remember from a few lessons ago, because this negative is inside the parentheses, it's being squared. It's part of the fraction. So therefore I write it like this. 2 negatives give you a positive answer, and I'll put that plus sign just to remind me that it's a positive. Then I multiply my numerators. 3 times 3 is 9. Multiplied my denominators. 4 times 4 is 16. And I am done. Okay, example 8. I'm going to stick some fractions together here and square them and then multiply it by 1/2. So let's go ahead and square the 5/6. I'm going to do the shortcut. 5 times 5 is 25. 6 times 6 is 36. Okay, because 5 over 6 squared is the same as 5 over 6 times 5 over 6. So I'm multiplying my numerators, multiplying my denominators, and I get 25 over 36. then I multiply by 1/2, or I'm taking half of that. Remember, I said when you take a half, you double the denominator and put the numerator on top and you're done. So that's 25 over 72. All right, example 9, we've already done some just like that, so I'm going to jump up to example number 10. And it says find 1/2 of 2/3. The word of in math almost always means multiply. So if I say 1/2 of 2/3, it means I'm going to multiply 1/2 times 2/3. So all I'm doing is replacing the word of with a multiplication. And I multiply that through, and I get 2, 6, which reduces to 1/3. Or if you look back at before I did any of this, I could cross out the 2 here and the 2 here and get 1 over 3. So if you look at example 11, it says that what is 3/4 of 12? And again, the word of is multiply, so I'm just going to replace the word of with a multiplication sign. Make the 12 a 12 over 1. And I'm going to go ahead and write this as a product of primes. 3 over 2 times 2 times 2 times 2 times 3 over 1. And then it makes it real easy for me to cancel these two 2's with these two. And 3/4 times 12 is 3 times 3, which is what I have there, and I have a 1 there, so I've just got 9. Okay, so that is it as far as 2.3 multiplication with fractions. I'm going to do a 2.3b as in boy, where we're going to find the area of triangles.